Okay, so moving on to another kind of question. These kinds of question are more demanding. They not only need you to understand what kind of solution will be formed, whether acidic, neutral, or alkaline solution will be formed when the salt dissolves in water. This kind of questions demands that you can calculate the exact pH of the salt solution when the salt is dissolved in water. So let's take a look at this question. Calculate the pH of a solution when 0.1 mol dm³ of ammonium chloride is dissolved in water at 25 degrees Celsius. And the Kb of NH3 is given here. So, just to recap, how to figure out what is the general range of the pH values. Your NH4Cl, when we split them up into this anion and cation, your Cl minus being a weak conjugate base of HCl will make it a weak conjugate base, and therefore it will not hydrolyze in water. So on the side of the anion, the pH will be 7, but your cation is NH4 plus, which is a conjugate acid of the weak base ammonia. So since ammonia is a weak base, this makes your NH4 plus a strong conjugate acid. So let me write out the equilibrium reaction. When your NH4 plus, since it's a strong conjugate acid, is able to transfer a proton to water to form H3O plus and NH3. So already you know that the pH should be lesser than 7 because there's a presence of more H plus ions than OH minus ions. So but how exactly can we calculate the exact pH of this concentration of 0.1 mol dm³ of ammonium chloride? We can still use the ice table that we learned in level 2 when we are using to find the pH of a weak acid or a weak base. So our I, which indicates initial concentration, will be 0.1, and here will be dash dash. H2O is not part of this because it's in liquid form, so we won't really consider it. So let's assume that there will be a loss of minus X amount of concentration of NH4 plus and a gain of X for NH3 and also H3O plus. So yeah, hopefully y'all will be already familiar with this ice table already. So what is the equilibrium constant here? The equilibrium constant, since this is equilibrium for acid, conjugate acid, right? So by right it should be a Ka equilibrium constant. So if you write out, is a product divided by reactant, right? So this. Okay, that's my last space. We use the next slide. Okay, so just to recap, our Ka expression would be NH3O plus and NH4 plus. Okay, so how do we exactly calculate or get the value of Ka? I'm not sure if you guys are familiar with this relationship between Ka and Kb, but essentially the Ka and Kb, where the Ka is, for example, the NH4 plus and Kb is for the NH3, will be actually equals to Kw, which is 1 times 10 to the power negative 14. If you guys stay after the video is after the outro is ended, you guys can also see how do you actually derive this relationship. But for now, since we have the value of Kb of NH3 stated, our Ka is actually just Kw divided by Kb. That means 1 times 10 to the power negative 14 divided by 1.82 times 10 to the power negative 5, which is equals to your x squared over 0.1 minus x. Yeah, you can go back maybe 1 minute rewind to see how do I derive this. But yeah, so let me just use my calculator. So in other words, 5.495 times 10 to the power negative 10 equals to this. And of course, we can always use the, since x is way smaller than 0.1, so basically your x squared will just equal to 0.1 multiplied by your Ka value. Then you can just square root it, and square root no space, which gives you 7.41 times 10 to the power negative 6. So that's the concentration of your H plus or H3O plus ions produced. So now pH, you can just simply negative log this, and 5.13. And that's how you calculate the pH of the exact pH of salt hydrolysis. And we come to the end of our level 3 for our acid-base equilibrium series. Hopefully you guys can finally understand the concepts behind salt hydrolysis, as well as how to calculate the pH of salt solutions that will be acidic or alkaline in water. But just to wrap up, this 40 minutes of video of content can be just condensed into these 3 pointers. So when does salt hydrolysis occur? Firstly, your anion of salt has to be a conjugate base of a weak acid. So remember, the weak acid will give you a strong conjugate base, and since it's a strong conjugate base, you are able to deprotonate water to give you OH minus ions, and therefore the overall pH will be more than 7 since it's an alkaline solution. So vice versa for the second point, the cation has to be a conjugate acid of a weak base. So a weak base gives you a strong conjugate acid. Strong conjugate acid will be able to protonate your water molecules to give you H3O plus ions, therefore your pH should be lesser than 7. And last but not least, your cation has to be a metal cation with high charge density. So with a high charge density, it will be able to form a complex ion, and as a result of a long explanation, you are able to produce H3O plus ions, which will be acidic, and therefore the pH will be less than 7. And formula wise, we can hopefully you guys will know how to write a hydrolysis equilibrium equation, and from there, using the ice table as well as the formula Ka times Kb equals Kw, which is 1 times 10 to the power negative 14, you guys are able to calculate the exact pH of a salt solution if the question demands you to do so. And when would this salt hydrolysis thing be relevant in our grand scheme of conquering acid-base equilibrium series? You guys will see it more in level 5 when we combine all the knowledge we learned from level 1 to level 4 to help figure out how to sketch a titration curve, or how to plot a very nice titration curve. Okay, so that's the end of our video. If you want to stay longer, because we can also, there's sort of an appendix for you all to find out how does the Ka times Kb equals Kw relationship comes about. But if not, thank you so much for staying with us throughout this whole, or staying with me throughout this whole 40 minutes, and hopefully you guys learned something out of this 40 minutes lecture. And yeah,